All right, welcome calculus people to the beginning of Unit 3 where we start jumping into derivatives. But before we get to derivatives, we need to understand the idea of average rate of change and instantaneous rate of change. And tangent lines, these things called tangent lines. So we're going to be looking at tangent, slopes, normals. Maybe you're normal, maybe you're not, who knows. But let's go ahead and take a look here. So first thing we're going to do is look at a thing called a secant line. A secant line is essentially a line that connects 2 points on a curve. A curve being any kind of line. So if I was to give you some sort of line that looks like this, I could find the slope between P and Q here. And the slope of that line would be, well, I'm not talking about slope. This is a secant line, the line between P and Q. And we could find the slope of that line and anything we wanted to do. The slope of this line is actually, what you'll see in a second, is the average, if I could spell here, average rate of change. This is the average rate of change between P and Q. So if I was to give the function x cubed minus x, if you were to graph this on your calculator, you would have zeros at -1, 0, and 1, and it would go something along this line here. I could find the average rate of change, or the slope of the secant line. Please pay big note to this question here. The average rate of change is just the slope between 2 points. And I want to go between 1 and 3, so somewhere up here. So that's basically saying I want to find the slope. So the change in y, so delta y over delta x. So the change in y is going to be f of 3 minus f of 1 all over 3 minus 1. Notice this is slope. The change in y over change in x. Well, f of 3 is 24 minus f of 1, which is 0, over 3 minus 1 is 2. So therefore, the average rate of change is 12. Ooh, that's a lovely 2. 12. So we just found the slope of the secant line between the points x equals 1 and x equals 3, or on that interval from 1 to 3. As, this is very important for us to understand, this is where the limits connect into derivatives and tangents. If I was to do this, and I had the point P and I had the point Q, or Q and P, whichever one I want to do here, I could get some sort of secant line between P and Q. As Q approaches P, so now I have Q up here, and as Q gets closer and closer and closer and closer and closer, it gets closer and closer to P, the slope of the secant line limits to the slope of the tangent line. I mean, the limit as Q approaches P is the slope of the tangent line, and we're going to write that a little bit differently here in a few seconds. Basically saying, as the x values, as the distance between the two x values goes to 0, as x goes towards 0, the slope of the secant line comes close to the slope of the tangent line. Tangent line being just the line that comes down, touches P, and continues on. That's the only point of contact. Excuse me. So the tangent line, as I just mentioned, is a line that touches a curve at one single point. That's it. It's called the point of tangency. You're basically going to be finding the slope between 2 points. And if you recall last year, we did do this in my class. So if we have the point a comma f of a and some distance h away, or h away this way, doesn't matter, a plus h and f of a plus h, let's try this a little bit differently here. I like this version. There's two versions of the equation here. I can find the slope between those two lines, and I can say as h goes towards 0, it becomes the tangent line. So we're looking to calculate the limit as the limit goes to 0. So basically, it's the same idea as the secant line, where this is a y value and this is a y value, minus the x value from the x value. And it becomes this. This is one of our biggest definitions of everything we do in calculus. This is the definition of the slope of the tangent line at x equals a. So this is the slope of tangent line at x equals a. This should probably be highlighted in boldface writing, underlined, boxed, bubbled, whatever, in order for you to remember this. So this says the limit as h approaches 0 of this fraction. So we did f of a minus f of a plus h minus f of a over a plus h minus a, just being a slope. Notice here that a plus h minus a, the a's cancel, and I'm left with the h. And we can calculate any type of slopes. If I was to want to find the slope, let me go ahead and do the example on this page here. If my function was f of x equals 2x squared, and I wanted to find the slope at if I wanted to find the slope at x equals 3, I would do the limit as h approaches 0 of f of 3 plus h minus f of 3 all over h. And I would just continue, or just do the process. If I plugged in 3 plus h into the function, this would be 2 times 3 plus h squared minus f of 3. 3 squared is 9 times 2 is 18. All over h. And I just have to do the math. 3 plus h squared is 9 times 2 is 18, plus 6h times 2 is 12, plus h squared times 2 is 2h squared, minus 18 all over h. You notice h can't be 0, but we're talking about the limit, which means we can do some canceling. You might remember this from last year. 18 minus 18 is 0, so I get 12h plus 2h squared over h. The h cancels, so I get 12 plus 2h. And I can evaluate the limit now as h goes to 0. That thing goes to 0. And I'm left with a 12. That means the slope of the tangent line at x equals 2, or sorry, at x equals 3, is 12. If I wanted to find the equation of the tangent line, well, that's just going to be y equals my slope times the point slope form says x minus x equals 3. And whatever the y value is. If I plug in 3, I get 9 times 2 is 18. So there's the equation of the tangent line, which kind of pulls me into the normal line here. If I was to go to this, the normal line is the line perpendicular to the tangent. You just have to remember, if you have slopes, it's the opposite reciprocal. So if I gave you the slope of 12, the normal line slope would be negative 1 over 12. That's going to finish us off. Here's your assignment. I will try to get you guys your assignment sheet tomorrow with all of your worksheets on them. I'll start sharing items tonight. And so they'll be on the Google Drive whenever you guys need them. I hope this made sense, and I hope to see you guys tomorrow. Have a good evening.